Hey, welcome to this tutorial series. We're going to start this series on distributed systems. Uh, Today we are going to look into how do we solve scalability problems using caching. And we also are going to look into some of the caching strategies and how caches can be used to solve scalability problems. So what's a cache? Caches are high-speed data storage layers which contains subset of the data. The data stored in caches are frequently accessed and served fast. Cache is an intermediate and a transient storage layer. It lies in between the underlying data sink and the layer which accesses the data. Caches can be in memory, distributed, and it can also be an edge. Edge caches are also called CDNs. So, so why caches are intermediate? As we said, caches can be in memory, which you can easily correlate to a hash map where the data access time is O of 1 and it can be served from the intermediate layer. But in that case, if the application restarts or hard restarts, the caches are also getting the entire cache is lost and it gets evicted. So we are going to talk or focus more on a distributed cache where it lies in between or outside the process of the application layer, but it is separate from the database layer. So when a system operates at a peak capacity and it encounters sudden spike or load, reads from the database becomes costlier. It takes more time because the underlying data sink, this DB access layer, is going to serve the writes also. It has to serve the reads also. How do we solve this problem? Or traditionally, how this problem is solved is by replicating the data. Whenever the data is written, for redundancy purposes, as well as to ensure that it can be read from a different instance, the data from the data sink is replicated to more than one machines or more than one servers or more than one containers or wherever it is, so that all the reads can be routed to the read instances. Underlying, we can also design the data in such a way that some data is sharded. So all the country specific data resides in one server and the other country specific data resides in the other server, so that the underlying data is sharded and it also enables us to fast access, because if the entire continent data is stored in one server, it takes long time to read. Both the application and sharding are done at the DB layer, or it has to be done fundamentally at the start. It's not a exercise which people usually will do post-mortem. But is there any other way that we can do fundamentally? Yeah, there comes cache. Caching. Caching is done independent of the database layer. Why do we say that? Because caches has to reduce the load on the database, because the database, as I said, the database is going to handle the read as well as the write. Caches are done to offload the operations in the DB and to provide faster responses to user queries. Caches is a performance optimization strategy. Okay. Caches are transient, or caches serves as a transient storage layer, serving the user request faster. It improves the experience and it improves the IOPS. So why caches are transient? Because usually caches are not backed up with a disk storage, because if the cache server itself restarts, there are few caching engines which are backed up with underlying disk storage, so that if the cache itself restart on a cold restart, it will come up with the already loaded data. But that's not the case, because most of the cache data is served from the main memory, not from the underlying disk. It improves the IOPS. It improves the IOPS of the DB. Okay, because the data is not seeked from the database. Usually, most of the databases, the data is seeked because the data underlying data is indexed. Whenever the data is indexed, it takes log n time to go and look into the index, or mostly that time. But caches are more of a lookup. It takes a constant time to get the data. Um, Cache could also be written back to the disk, but it need not be necessary. Cache data may not be immediately consistent. but are eventually consistent. This is an important point which we will touch base on this in the upcoming slides. So we'll look into the internals of cache and cache storage. Caches are usually key value stores because we want to have a faster look into the data. We don't want to query a range of values from cache, but though it is possible in Redis, in Hazel Cache, we can query a range of keys. It's not necessary that I will do a lookup based on one key. I might be able to look up into a range of keys as well. But usually, it's not how the data is accessed, but it can also be the case. Uh, if we start looking into a lookup, mostly it is to do with the key value store. But some of the cache engines support different data types as well. For example, linked list or cache storage also offers set based storage. But we will primarily focus on this in this tutorial. We will be focusing only on the lookups. But there are other storage mechanism available. It's when you get a complete understanding of how cache works, we can obviously translate that into other data sections as well, which how it can be accessed when it is put in the cache. That's a simple thing. Caches are usually not backed up by the disk. Why? Because the underlying layer is persisted in the disk. So we don't want a transient layer which is in between also to be persisting the data unless for redundancy purpose. For example, if we have a distributed cache and it can serve the data much faster and the underlying data is backed up or not backed up, it's been stored in the database, which offers consistent data storage mechanism. Why do we need to have the same data stored, except for the use case for to serve the cold restart? The caches, if the distributed caches also ensures that if one region or one availability region goes down, the data can be served from the other region, ensuring there is a minimal latency or a minimal cutover when the data is not available, which will be a few milliseconds, and the request can be routed to the other region as such. So it need not be backed up with the storage. Candidates. So how do we ensure that this data is a candidate for to be cached? They are heavily read multiple times. That data is a candidate to be cached. Also, there is no need of immediate consistency or strong consistency. For example, if the underlying data is modified, I don't want that to be reflected all the time. I can be eventually consistent. Some of the people are okay with little looking into a little older version of the data. That data can be served as from the cache. Caches also eliminate data hotspots. What is a data hotspot? For example, if a game is getting played, or if an election is happening, or if a war is happening, or if a stock market is news is happening, many people will look into some part of the data. For example, people will look into a result of a particular company stock value on the result day. It will encounter lot of hits, but that data can be served, or if it is distributed, if the underlying data is persisted in a particular shard, for example, a divided shard also, that area will require much frequent queries. For example, the president of India or United States uh, puts a tweet, that data goes into a particular storage layer, and that data will be much frequently accessed because it provides more value. So that is called hotspot. So only that particular node receives lot of read, but others will have equal reads. So how do we avoid that? We can put the data in the cache and serve it. Ensures that the hotspots in the data sink layer is not getting created. It provides predictable performance. What happens is if too many requests are coming on a particular DB node, there are chances that the response times might become little slower, or the DB server might not be able to handle. So what happens here? If we put the data into the cache, because the data is in main memory and it is if main memory is much faster, it serves the data much faster. But in DB, it has to be seeked. Okay. So it ensures that I will be able to, or the users will be able to get a predictable performance on much frequently accessed items. It reduces the IOPS. How? If the underlying data is not seeked but it is fetched on a key value store, It's a constant time. It takes a constant time. Also, the application layer access from an intermediate layer, not going to the underlying disk storage layer. So that way, the IOPS on the database layer is reduced. It improves the performance of the DB because not too many reads are being fired into the DB because the data is served from the cache. It reduces the load on the backend and improves the application performance. It's a very good point that we need to discuss. How would caches reduce the load on backend? If assume that if too many requests are coming on backend server and that backend server is trying to point to a database to read. If the data underlying data layer is behaving little slowly, the application server threads will be waiting for the data to be served. That will not happen in a single threaded application. But what happens is too many requests will be waiting for the event to be filled up. So that happens, when that happens, the user experience gets delayed. So in this way, the entire load on the backend will get reduced and it improves the application performance. What are the other candidates that can be cached? HTTP sessions, DNS names, shopping cart, frequently liked items, famous personality tweet, or an image posted by a personality which is going to become viral. All these are candidates for caches. Okay, now we will talk about cache and cache consistency. So cache itself is an intermediate layer. What is that we are talking about cache consistency? Okay, let's understand what are the different consistency mechanisms which are available and what are those consistent mechanisms which the cache server would be able to live with less trouble, but it adds more value to the underlying use case scenarios is what we are going to look into this slide. The DB layer serves as a source of truth because the data is persisted in a durable manner. Most likely caches are main memory. As I said, it could be backed up, but the underlying source of truth is DB, not the cache. When the data is served from cache, there is a need for the data to be in sync because there is an intermediate layer, which is another hop. And whenever the underlying data gets modified or mutated, the cache also has to reflect the original data eventually so that the data can be served. What are the three consistency mechanisms that we can say? Strong consistency. Strong consistency is if the underlying data is modified, everybody, everybody who writes or reads the data after the data is written sees the same version of the data. It is called strong consistency, or usually it's called transactional consistency also. But let's not go into transactional consistency, which is a very vast topic. Strong consistency means everybody who reads the data after it is written gets the same version of the data. It's called strong consistency. There is another consistency which is called immediate consistency. Immediate consistency is read what you write. Anybody, the same user who writes the data, when they immediately read the data, they get the latest copy. It doesn't mean that everybody gets the data. There is a mild difference between strong consistency and immediate consistency. Immediate consistency means read what you write. If I wrote the data, if I updated my phone number, next time when I am getting an OTP on that use case, I would be getting on an updated phone number. But if somebody wants to look into the phone number and make a call, they might not see the updated data soon. This will maybe consistency is offered in modern NoSQL databases where it offers read what you write, but the data gets replicated to minimum n number of nodes, which is in the core RAM. But all in-sync replicas will only the in-sync replicas will get, but all the replicas might take some more time to get. That's called immediate consistency. Eventual consistency, it is called weak consistency. What it means is the data gets returned to the data storage layer, but not everybody sees the data immediately. But eventually, it's eventually doesn't mean hours altogether, but in few fractions of milliseconds or maximum within a second, everybody gets to see the consistent view of the data. This is the best candidate for caching. Caches could be used as a mechanism to serve reads and writes faster in eventually consistent scenarios. Many systems Do not use cache to write also. So as we talked about eventual consistency, uh, asynchronous reads are the scenarios where cache solves better. Okay. When write happens, the write happens to the underlying storage area. Usually, writes are not the problem which cache solves. Write heavy scenarios, write spikes are not handled by caches, but read spikes are handled by caches. What do I mean by that? What's a write spike and what's a read spike? Suddenly, some 100,000 orders are coming. I don't want to lose a single order, but my underlying database or anybody will not support 100,000. So how do I scale it? Probably we will introduce an intermediate system, but need not be a cache layer, like a pub sub system or a write ahead log. We will write to the write ahead log, which is an append only data store, maybe Kafka, maybe Red Panda, maybe a queue, and then push it to that and then say that your request is accepted. Be guaranteed that the data will be written back. That's called write heavy system. Usually in these scenarios, data is not written to the cache. I have not personally written to the cache first in my all experience, but it is not an anti-pattern as well. It doesn't mean that you should not use, but yes, in read-heavy system, what people will do is when the underlying data has to be read, there's a sudden spike in a lot of it. For example, uh, somebody has declared a result. Some company has declared a result on a on the stock. The profit of the company has quadrupled. So everybody wants to check the result of the data. So that spike can be handled by putting the data. The results can be updated to the cache, and then that data can be served from the cache. The writes usually will be done scaled via asynchronous manner by queues and pub subsystems. Reads are handled by caches. In modern systems that could be eventually consistent, cache are not used to do the write first, rather pub subsystem. That's what we discussed, but used to reduce the read load. Okay. With that, we will take a pause on this first part. In the next step, we will look into some of the caching patterns.